So last time we talked about how to look at the varying, changing prices over time and use this concept of the consumer price index to convert prices into the same year. So the last example we did was we said, okay, when a senator made $133,600 in 1994, multiplying by the appropriate ratio from the consumer price index, that would be like making or equivalent to making $233,381 in the year 2014. So those two salaries are equivalent. So making $133,600 in 1994 would have been like making that $213,000 value in the year 2014. So what we want to do now is we want to do that same multiplying by a ratio from the consumer price index approach, but to do it to an entire spreadsheet of data and then analyze the results that we see. So the first thing that I already have open here, just going to the usual web page that you've hopefully been working with all semester, open the data set median price of new homes, and that's the data set that I have over here on the right hand side in Excel. So again, generally it looks like, prices of homes were on the increase. Of course, we did have the housing markets, that bubble kind of burst, and then there was a decline in values there. But, for the most part, most things that we study over time generally increase. And that's generally what we see here, except for those last few years. So what we want to do, though, is we want to look at, well, what does that mean in terms of what the other costs were doing over that same time frame? Meaning, well, while it's fine to look at just those nominal prices, if other things were rising either faster than the prices of homes, or maybe other things were rising slower than this, then maybe these increases were just keeping pace with what we're going to talk about, just keeping pace with inflation. Or maybe these increases were more than that. So how can we determine that? And that's where we need to convert these into constant dollars. So that's what we're going to do now. So the first thing we need to do is you'll also need to open from the usual website, you need to open the data set that is down here, the Consumer Price Index. It says CPI. You need to open that Excel file as well. I already have it opened because we're going to need that one. And essentially what we're going to need to do is we're going to need to add a column for the Consumer Price Index. So we need to, CPI, we need to paste the values for the Consumer Price Index for these years, 1979 all the way up to 2009. So 1979 to 2009. So let me open my CPI. And again, I need 1979 to 2009. So 1979 starts here, and then copying down to the year 2009 ends at the 214.5. So we want to copy those values and then paste those into our spreadsheet here with home prices. All right, so with that in place, this is now going to allow us to then make a conversion. What we're going to have in this last column is going to be the median sales, get that out of the way, sorry, median sales price, but we're going to convert this into the most current year we're looking at, which is 2009. So we're going to convert these into constant $2009. So when the median sales price of a home in 1979 was $62,900, we want to ask ourselves, what would that be like paying for a house in the year 2009? So when, your aunt and uncle say, oh yeah, we only spent $63,000 for our first house that we bought in 1979. what would that have been equivalent to paying, or what would that have been like paying in the year 2009? And we're going to do that for the whole spreadsheet. So you can see over here, this is in your notes, and this is really crucial as we're typing this in. We're doing the same ratio that we did last time, where we're going to start off with our equal sign, of course, and we're going to cell reference the original price that we're trying to convert. We cell reference because that's something I'm going to want to change from row to row, times, and I'll go ahead and put this in parentheses for emphasis here. You don't really need it to be, but it'll look most like what we did last time if I do that. So what am I going to be multiplying by now? I'm going to be multiplying by this ratio right here from the Consumer Price Index. So I need to multiply by the year, the CPI value of the year I'm trying to convert into, divided by the CPI of the current year. So that's what we're going to be doing here. All right, so back in my Excel here, the thing I need to be careful of is, yes, I want to convert all of these values into constant 2009 dollars. So it's tempting to think at first, well, let's just cell reference that. That's the value I want from the Consumer Price Index. That's the year I'm trying to go into. And then divide that by the year I'm trying to get out of, which is the current year. And then we'll close that parenthesis and hit enter. Now, certainly when I do that, I get the right answer here for 1979. You can compare it in your notes with what you see there. But here's the problem. If I try to fill this spreadsheet, I start to get zeros here. So what's happening? If we double click, we can kind of see, all right, the B7 looks good, times, and then divided by the C7 looks good. But this cell C37, because I cell referenced the year I'm trying to convert into for all of these, it was down here. I had cell referenced this one. I had cell referenced C36. Cell references will vary. They're variables in Excel. And I don't want it to. So now it's dropping this down every time to empty cells where there's nothing below it. So here's what, remember, I typically say is if you're trying to do something that's going to vary, then yes, you do a cell reference because that's your variable. But in this case, I don't want the 214.5 to vary. I'm converting every year into 2009 dollars, so I don't want that 214.5 to vary. So if I want it to be a constant, I'm just going to type it in like a constant. That's probably the easiest way to think about it. Now, same value for the first one, but now the rest of them are going to work when we fill the spreadsheet. So now again, just kind of tap on one of these and make sure it's doing what you want it to do. It's taking the original value for that year times the CPI of the year I want to go into, and then divided by the CPI of the year I'm trying to get out of. So that is exactly what we want to have happen. All right, so that's how you convert an entire spreadsheet of values from nominal dollars into constant dollars. Now, if we were to make a graph, we can highlight our years here. And then if I go back up, hold down with the control button and then highlight column D. And that's how you can skip all those values in the center, control highlight. And then if I just look at a scatter plot here, and again, this will be over here in your notes, so just a basic scatter plot. So now we see something very different than the one that we first just did in nominal dollars. So if we went back to the one that I had in the notes, this was the graph in nominal dollars. So in nominal dollars, it's much more of just this kind of constant increase with the exception of the few last years. Now what we get is we get some decreases, some increases, some decreases, some areas that are more level. Generally speaking, kind of less variance overall. Over in the nominal dollars graph, we started, down just over 50,000, went all the way up to 250. And then over here, notice we're basically ranging from around 150 up to, a little over 250. So less variance overall, and definitely some areas of decrease as well as increase in areas that are level. Okay, so this is really what we need in order to make comparisons and to study trends of how prices of something might be changing over time. So let's analyze this graph and talk about some of the features that you'll need to really look for when you're analyzing these graphs. All right, so oops, that's what we just did here. Next page. Here we go. So these are the observations that I want you to make. So we still have our graph over here on the right-hand side, so you can kind of keep that in mind as we're looking here. So regions, first of all, let's just keep one thing in mind, that generally speaking, in nominal dollars, the median price of homes was generally increasing. So in nominal dollars, again, going back, the median price of homes was generally increasing. Now, here we are studying what did those increases mean when we converted them into constant dollars. So focusing on regions where the constant dollars graph, so this graph we just found, are also increasing. So maybe I highlighted a couple in the notes. So regions like from 1985 to 1989, and I said, where else did I say? Oh, like from 2000 to 2005. So, let's focus like right there. So regions of the graph that are also in constant dollars increasing. That meant that those increases that we were seeing in nominal dollars were actually increasing more than what other goods and services were increasing over that time period. So here's the thing, where the constant dollars graph is increasing, it meant that the increases that we were seeing in nominal dollars were increasing more than inflation. They were increasing more than what other things were increasing over that time period. Okay, so let's just focus on the early 2000s. In the early 2000s, home prices were increasing more than what other things were increasing. They were increasing more than what groceries were increasing by, or they were increasing more than maybe what people's salaries were increasing, or they were increasing more than the price of insurance or medical, or whatever it might be. But generally, when you see constant dollars increasing, it meant that the increases in nominal dollars were increasing more than inflation. All right, now regions where the constant dollars graph is relatively constant. So now we're focusing on where the constant dollars graph is relatively constant. So in the notes I say, okay, maybe like from 92 to 97, somewhere in here. Okay, so in the mid-90s, the constant dollars graph was relatively constant. All right, so again, keeping in mind that home prices in reality were generally increasing, that means that the increases that were happening were just keeping pace with what other costs were doing in that time period. So the home prices, yeah, they may have been increasing. If I look back in the mid-90s, home prices, in fact, let's just pull this out of the way here. Maybe we can, maybe I can pull this out of the way. Why does my graph not want, there we go. So if I slide my graph over, look at the home prices in the mid-90s, right? They were still going up. These are nominal dollars in column B. So in the mid-90s, home prices were still going up. Nominally, home prices were rising. But those increases, when we're converting to constant dollars, are relatively constant themselves. So that means that home prices were increasing at a rate that was just keeping pace with the other increases of that time period, or they were rising about the same as other costs were, or they were just keeping pace with inflation. That's another way to say it. All right, now where the constant dollars graph is decreasing. So let's look at, what did I say in the notes? 1979 to 1982. I don't have 79 to 82. I don't have that in this graph. I don't know. That might be a typo. I apologize. Maybe 2005 to 2007. So I might not have, for some reason, grabbed the entire data set. I don't have what was happening in the 70s. All right, so let's just focus right here. 2005 to 2007. So there's a little decrease there that's happening in constant dollars. If I look down here, though, let me scroll my spreadsheet. From 2005 to 2007, notice that home prices were still creeping up a little bit, like right here. Oops, scroll, there we go. 240,000, 46, 247.9. So the median home price was increasing in nominal dollars, but in constant dollars, it was decreasing. So what does that mean? So when the constant dollars graph is decreasing, so where the constant dollars graph is decreasing, it meant that the increases of the nominal dollars, the increases of those time, were increasing less than the cost of other increases of the time. So they were increasing at a pace that was less than inflation. So those increases in home prices were not even keeping pace with what other increases were during those years. So that's the most common set of interpretations, because most of the examples that I'm going to work with in your activities and your assignments are going to be based on a set of nominal dollars that were increasing over time. Now, sometimes you can have nominal dollars that do actually decrease themselves. Like if we look at what happened over the last few years, those nominal dollars were actually decreasing. So it's not surprising that the constant dollars were also decreasing, and it just then has to do with kind of that they were actually decreasing maybe quicker than in constant dollars than what other in that time period, then maybe they were maybe decreasing faster than other things. But generally speaking, I'm not going to really worry so much about that situation. I'm going to have us focusing on the situations where the nominal dollars graph was increasing. And so these are the interpretations that I really want you to be able to make when you're looking at the constant dollars graph. All right, so let's look at another example. So this one is going to be, has nothing to do with our data here, so it's based entirely on this example. So on this one, it says we have we did an example with this last time, U.S. Senators' salaries. And so again, note that we kind of start off here saying that in nominal dollars, that senators' salaries were increasing, or in some years remaining the same. So note that in nominal dollars, senators' salaries were generally either staying the same or increasing. All right, so with that in the back of our mind, these are the types of questions that I want you to be able to answer given a graph in constant dollars. Okay, so the first one here, so now we're just going to focus on this graph and not look at the Excel stuff that we have there. All right, so first question. Were the salaries of U.S. senators rising less than, more than, or about the same as what other goods and services were increasing from 1997 to the year 2004? All right, so 97 to 2004. So maybe, I don't know, roughly in here, let's just say. So that's going to be our 97 to 2004. So when the constant dollars graph is relatively flat, that meant that whatever increases were happening over that time period, their salaries were basically just keeping pace with inflation. Okay, so their salaries were increasing about the same as what everything else was in that time period. So even if they were getting some raises, let's say, whatever the actual numbers were in nominal dollars, those raises, those changes were just basically keeping pace with inflation because the constant dollars graph is relatively flat. All right. Next one says where the salary increases for U.S. senators rising, again, less than, more than, or about the same as other goods and services from 1969 to 1975. So let's take a look at this part of the graph. So 69 to 75. All right, so 69 to 75, right about here. All right, so that's this portion, so 69 to 75. So that is decreasing, okay, relatively significantly decreasing there. So that meant that whatever the senator's salaries, if they were getting a raise or if it says that they were either staying the same or they were getting small increases, or increases, I shouldn't say small. So that means that during that time frame, the senator's salaries were rising less than what other prices were increasing at that time. So their salary is not keeping pace with inflation. So if you were a U.S. Senator, you're getting less buying power for your salary in 1975 than you were in 1969. So in reality, what was probably happening in this time frame is they maybe weren't getting any increases, like their salary was the same, but the buying power of an unchanged salary decreases over time because as the years go on, generally other things are increasing, your cost of groceries and medical expenses and your other rents and car stuff and all that all those things are generally increasing. So if in reality your salary is staying the same or you're getting very, very small increases, your actual buying power of that unchanged or very smallly increasing salary is really decreasing over time. So at the end of 1975, they can do less with their salary than they were able to do in 1969. In fact, it looks like 1969 is the year that their salary had the most buying power. That was the year when being a senator, right here, the peak of this graph, that was the year that being a senator was the most lucrative. All right, last one, same question, this time for 1989 to 1991. So 89 to 91. 89 to 91 looks like it's these three. So a little increase in there. So we have a few years in there where there's a little increase. So if the salaries were increasing in constant dollars, that meant that in that brief interval of time, those few years, whatever increases the senators were getting, those increases were more than what other increases of goods and services were, or they were more than inflation. So because the constant dollars graph was increasing, they were getting salary raises that were more than what other goods and services were. So those are the kinds of questions that I expect that you can answer given a graph or studying a graph. And you're going to have an activity that's going to be on minimum wage, and you're going to end up with a constant dollars graph that's going to look pretty similar to this one. So similar types of questions. And the very last little question or example, I guess, here, first we're just defining what inflation is. It's just the percent change. So hopefully y'all remember that percent change when we talk about looking at percent change. It's just going to be new minus old over old. So if we're talking about the CPI, it's going to be the new value, the not earlier, that's the exact opposite, so let's say current year, minus the old or the previous year's CPI. So the old CPI, so new minus old divided by, again, old. So the old CPI. So inflation is really just this percent change in the CPI. So for example, inflation for 1996 is the percent change in CPI from 1995 to 1996. So it's new minus old divided by old. So new, current year. So think about in 1996, it's not yet 1997. This is the new year. And then minus the old year, and then divided by the old year. So the inflation rate for 1996 was 3%. So for example, in your individual assignment, I ask you to compute some sequence of years. I can't remember exactly what ones. I ask you to compute the inflation. So let's do a little bit of that here just so you'll know when you do that assignment. All right, so let's say I have you do it for like, I don't know, the 70s and 80s or something. So if I wanted to determine what the inflation was, so if I was going to determine inflation, so remember, inflation is just going to be the percent change in the CPI. So we would simply we would start with our equals. And so inflation for 1970 is going to be the CPI for 1970 minus the CPI for 1969, so new minus old in parentheses, divided by old. So if it's 1970, that's the new year minus the old year divided by the old year. So that's in its decimal form. We can quickly change it to a percent. Just use that little percent sign. I always like a couple of decimals, so let's increase that. So inflation would have been 5.72% in 1970. And then you could just fill, and you can see, I mean, there were some really large inflation rates if you look here, just visually, even in the 70s and 80s. So there was a lot of inflation, which sounds really bad, but it also, at the same time, it meant that interest rates were really good too. So that was actually a good thing. But if you were asked then, let's say, to graph this or graph some of these inflation years, remember you can highlight your years. So let's say I highlighted, I don't know, just from here to here or something. Well, I'll go down to 2014. Okay, so I've highlighted from 1970. So then I can skip and go over to column C. If now on my keyboard I'm going to hit Control and hold down with my left mouse button and highlight column C, and then I'm going to go to my scatter plot. So I'm going Insert and Scatter. So the reason I'm going over this is there is a question in your assignment about this. So this is a little hard to kind of see visually. If you wanted to change the look of it, if you wanted to maybe add the I don't know what I was going to do here. Sorry, I lost my train of thought. But if we wanted to kind of just look at the graph itself, we can see that inflation was much higher in the 70s and 80s than it was in the 90s and 2000. Inflation was very, very low here, a lot of high inflation here. We might say a lot more variance kind of happening with that graph, which is true, but also just generally a lot higher in the 70s and 80s. The numbers are generally a lot larger than the 90s and today. So like I said, there is something I believe in your next individual assignment that involves inflation. So I did just want to go over that. All right, so you're going to be going on from here. You're going to be doing activity, let's see, 16. And I think for my class, I'm going to have you do most of it. So number 1 is going to be just kind of converting by hand. You're going to start with what the poverty level was in 1970. So you'll start with this 37.43, and then you will convert that into 1975 dollars, and then decide which one of those incomes actually was better or had more buying power. And then you're going to do some things with the minimum wage. We've done the senator salaries. You're going to do some similar things with the minimum wage. And I think I don't have a lot to throw out here. I think I will omit, let's say 8 and 9. So if you're in my class, I'm just going to have you do 1 through 7 for this group activity on the Consumer Price Index.